The points A and B have coordinates 5, 1, minus 2 and 4, minus 1, 3 respectively. The line L has this equation here. Find the vector equation of the line that passes through A and B. Show that the line that passes through A and B intersects the line L. And find the coordinates of the point of intersection P. The point C lies on L, such that the triangle PBC has a right angle at B. Find the coordinates of C. So let's have a little look at this then. Find the vector equation of the line. So here R, the vector equation, is equal to this point then through A and B along AB, so we can say it's 5i plus j minus 2k. So start from there, and it's going to, because we've used mu, we use lambda. And then b minus a, 4 minus 5 is minus 1. Minus 1 is minus 2. And then 3, take away minus 2 is plus 5k. So there's the vector equation of the line through the points A and B. Show that this line cuts out and find the coordinates of the point of intersection. Here's the line out. So for it to be compatible then, we need to show the x, y and z components are all the same at a particular value of mu and lambda. So minus 8 plus 5 mu, minus 8 plus 5 mu is the x component for the first line, is 5 minus lambda for the x component of the line AB. Then 5 and no j's, so it's just 5, is equal to 1 minus 2 lambda. So this is equation 2. This actually is equation, so what was it? 1 minus 2 lambda, sorry. So I'll put that in there. I was distracted by that being a 2. Should have written 1, of course. And then the third component, we need minus 6 minus 2 mu needs to equal the minus 2 plus 5 lambda. Okay, this one here, equation 2, will give us lambda, won't it? So here this implies straight away. You can see that this, to get 5, you need this to be minus 2. 1 plus 4 is 5, so straight away you can see that lambda is minus 2. So in that case we can read off mu from here. By equation 1 then, minus 8 plus 5 mu is equal to 5 minus lambda, 5 plus 2. Move the 8 over, 5 mu is equal to 7 plus 8 is 15. So that tells us what mu is then. Mu, 15 over 5 is 3, so there's mu. Now 3, let's see if it's compatible and has the same z component. Minus 6 minus 2 mu is equal to 3 minus 6 is minus 12, which equals minus 2 plus 5 times minus 2, which equals minus 12. Yep, that's fine. So lines intersect, or the lines cut each other at P. And the coordinates of P, well, lambda was, mu is 3, or lambda is minus 2, put it in here. The left-hand side will be the x, y, and z. So lambda, lambda is minus 2, 7. Minus 2, you get 5. Minus 2 here, minus 12. So there's the coordinates of the point P where they intersect. Now point C lies on L, the line L, such that the angle PBC is 90 degrees. Find the C coordinates. So let's have a look at that. Then I'm going to draw two lines. This is the line L, and this is the line through A to B. This is the point P where they intersect, and this was 7, 5 minus 12. Now we're told the angle PBC, there's a point C on this line L, such that the angle PBC, there's the point B. We're told that C is on L, such that angle PBC is 90. B has coordinates. Let's just go back and get them. 4, minus 1, 3. So let's put them in. 4, minus 1, 3. And then C has coordinates. Let's put the coordinates of C in. We can write them in terms of a parameter. So we can write C, and it's on the line L. So L is the line with the mu in, isn't it? So it's these components here, and I'm going to put a parameter t. So it's minus 8 plus 5t, 5, and minus 6 minus 2t. So I just put the x, y, and the z in here as the coordinates for a particular parameter value t, and that will be the point C. Now the point is that this vector here, this line here, is perpendicular to this vector here. Okay, so this is the directional vector AB, or we can use PB, can't we? So here, the vector PB, let's just do PB since it's there, dot BC, they're perpendicular, so the cosine of 90 is 0. So, what do we get then? PB, 4 minus 7 is minus 3, I, minus 1 minus 5 is minus 6j, 3 minus minus 12 is plus 15. Dot with BC. Now B to C is minus 8 plus 5t take 4, which is minus 12, plus 5t, I. 5 minus minus 1 is 6, so that's j. And then minus 6 minus 2t minus 3 is minus 9, minus 2tk. So there's our I, j, and k's. I, j, and k's. Dot product. So what do we get then? Let's see. So minus 3 times this is 36 minus 15t. Minus 3 times this is 36. Minus 3 times this is 15 minus 15t. Minus 6 times plus 6 is minus 36. So that's the second one. And then the third one is 15 times this. 15 nines, 135 minus 135. And then 15 times minus 2 is minus 30t equals 0. So the 36 is cancelled, thankfully. We've got minus 45t, which we can move over to the right. And that's equal to the minus 135, which is on the left. So that tells us what t is. Divided by 45, 135 divided by 45 is 3 with a minus. So t is minus 3. So we can read off the coordinates of C now. So C has coordinates minus 8 plus 5t. T is minus 3. So put it in here and here. Minus 23, minus 15, minus 8 is minus 23. The second component is 5. And the t value minus 3 in here, 6. Take 6 is 0. So there's the coordinates of the point C.